This must be one of the most unattractive minerals that I've shown you as part of this theme. It really doesn't look like anything special. It's quite dull in appearance, not much of a luster. You can see perhaps a hint of a crystal form in there. But it's not the type of mineral that we're going to find on prominent display, say in the National Museum. Even if I show you its name, this is euxenite, it really doesn't tell us very much about this particular specimen. It's only when we look at its chemical composition that we start to see the real value of this. Euxenite is an extremely valuable mineral. You can see there's a mixture of all sorts of unusual elements. These metals, the yttrium, the niobium, the tantalum, the titanium, these include some of what we call the rare earth elements. These elements occur in very low concentrations around the world. Yet, as we'll see, they're essential for the energy future that we need to move to. If we're going to move away from fossil fuels and electrify our energy sources, we're going to have to find a huge range of these rarer metals. So if you were to find a large deposit of euxenite, well, you'd be doing very well for yourself, I think. Let's start our investigation of this by looking a little bit at the geology of a smartphone. We've talked already in the course about the variety of materials and as a result the variety of rocks that need to go into making a smartphone. It's something we rarely think about. We sort of expect these phones to exist. We expect to be able to upgrade them maybe every couple of years, and there just to be new ones available for us. Yet we, as geologists, need to think about what actually goes into these. Go back to our first principles and the minerals that actually provide the materials that are required to make one of these devices. It's worth thinking as well, we're using the smartphone as an example, but all modern electronics are going to require a similar type of materials. The number of household items or vehicles that are now going to come equipped with a large screen for us to be able to control them. The number of devices that are going to be powered by lithium-ion batteries. So although we're going to focus on the smartphone, actually the issues we're going to uncover go way beyond just providing us with a mobile phone. Okay. To start then, I want us to think about the life cycle of a smartphone. I've given you a flow chart already drawn up. I'd like you to try and complete the rest of that flow chart. What I've called the stages in the boxes and the changes in the arrows. This is the flowchart I'd like you to complete. I've already put a couple of the stages in there. And these are the words I'd like you to use to complete the rest of the diagram. Once you've done that, and you might want to do that in pencil to start with, there's some digging deeper questions to have a go at as well. Okay. Press pause on the video now so you can see these words that you need to fill in and see what you can come up with. Okay then, let's have a look at this life cycle. It's going to start with a rock. I suppose it's inevitable. This particular rock is called lepidolite and is crucial for our modern life. Lepidolite is a major source of lithium. So by processing the rock, we can get a metal, lithium, which we can then manufacture into a battery, which we can then assemble into a phone, which we can then use until some point we decide to stop using it. We either then throw it away or it gets disassembled and we can change it back into the pure metal. This is the life cycle. Let's put some words in here, shall we? So we've got these different stages of our life cycle. If we put in the changes, there they are. This cycle, how these products are used, particularly for mobile phones, can be a fairly rapid one. Think about how often you might think about upgrading your phone. Think how often we might expect a new phone to be available. Yet we've got to try and find these ore minerals, including some very rare materials, even if they're only in small quantity, to make our phones work. If we look at the diagram you drew, let's put some words in on this, just so we can see everything's in the right place. Those are our stages, and these are our changes. Okay, press pause again now, just so you can check that you've got a complete set of answers. Okay. The digging deeper questions looked at energy. This is an estimate of the energy consumption for a mobile phone. It's interesting to see that actually the bulk of the energy expended on a phone, well, over half of the energy that it uses is actually at manufacturing stage. That includes mining the ore, refining the ore, and making the phone. The use over 2 years, maybe just over a third of the energy use. So all that charging that you do isn't the bulk of the energy use. And transporting it, often from the Far East, Korea or China. So where we're going to use it is actually a relatively small part of this. There's another video I'd like you to watch, all about the life cycle assessment. But we should also think about where geologists come in. Now, geologists really have a role in two places, and it can be the start and the end of the cycle. Finding and extracting the ore, obviously, but also if that product goes to landfill. Geologists are involved in designing and monitoring landfill sites in order to protect the environment. We'll see more about that in a later theme in the course. So, as we see the sunset on our mobile phone camera, the colours on that screen are the result of different elements, different minerals that go into the manufacture of this device. The electricity that's powering that device is stored in another set of minerals. The case that's being held is yet another set of minerals. And the electronics that make it all work, once again, a different set of minerals. So our next step, having considered the life cycle of a mobile phone, is to think about what actually goes into one. What are the ingredients? But that's for another lesson. I'll see you then.